Picture this. Somewhere in the pitch-black, freezing depths of the Arctic Ocean right now, there's a massive, ghostly shadow silently gliding beneath the ice. Now imagine that this exact same animal was already swimming through those exact same waters when the United States declared its independence back in 1776. I mean, it sounds like pure science fiction, doesn't it? But it's an absolute biological reality. Today, in this explainer, we're looking at an animal that totally defies the normal rules of biology. We are going to explore a creature that exists completely outside normal human time, operating on a scale so vast that it makes our entire modern civilization look like, well, a brief footnote.
Based on some incredibly rigorous scientific dating, the largest studied specimen of this species was born around the year 1627. Just pause and let that anchor in your mind for a second. 1627. When this specific shark was born, Shakespeare had only been dead for 11 years. The Mayflower had recently landed at Plymouth Rock. The whole concept of the United States as a nation, that wouldn't even exist for another century and a half. While human empires rose, fought global wars, and fell, this single animal was already navigating the deep ocean, just slowly growing, decade after decade, century after century.
Section 1. Older than America. The Deep Time Hook. Okay, let's dive into this timeline. So, meet the Greenland shark, or if we're being scientific, Somniosus microcephalus, which literally translates to sleepy smallhead. But please do not let that goofy name fool you. This is a massive apex predator. We're talking over 21 feet long and weighing more than a ton. It operates on a glacial timescale in the absolute most unforgiving, near-freezing waters of the North Atlantic and Arctic Oceans. Everything, and I mean everything about this shark is a masterclass in extreme, slow-burn survival. To really wrap our heads around it, look at how this builds some serious cognitive dissonance. 1620, the Mayflower sails. 1627, our shark is born. It survives the entirety of the American Revolution in 1776. It was quietly swimming deep below the surface when humanity took its first steps on the moon in 1969. And it is still alive today in 2026. Literally every human generation you've ever read about in a history book, all of our triumphs and tragedies happened within the lifespan of this one continuously swimming fish.
392. That is the estimated age in years of the largest female specimen dated by scientists in a landmark 2016 study. But what's truly terrifying here is that 392 is just the midpoint. When you factor in scientific confidence intervals, the maximum age for this exact shark could easily push past 500 years. 500 years! It's the longest living vertebrate ever confirmed on Earth. But honestly, extreme age is only the very beginning of this mystery.
Section 2. The Blindness Paradox and Survival in the Dark. As you can probably guess, survival over centuries in the deep Arctic is not a clean or easy process. If we shift our perspective downward from the grand sweep of human history to the macrobiological horror of the deep ocean, we find an animal that honestly looks physically broken. Most photographs of adult Greenland sharks show something pretty disturbing. Their eyes are milky, heavily scarred, and just seemingly ruined. That damage is caused by Amatocochia elongata. It's a 30mm pale pink parasitic copepod that has evolved to do exactly one gruesome thing. It permanently anchors itself directly into the cornea of the Greenland shark's eye. It literally feeds on the tissue, causing severe permanent scarring. And for decades, marine biologists just assumed this harsh reality left the shark functionally blind. It was widely accepted that these ancient giants were just swimming through the dark with heavily infected eyes, entirely unable to see a thing.
So what does this all mean? It naturally brings up a massive evolutionary contradiction. How does a massive, functionally blind predator manage to hunt and survive for 400 years? You'd think an animal robbed of its vision, suffering from extreme parasites, in a freezing ocean completely devoid of sunlight and overflowing with fast-moving prey, would just quickly starve, right?
That's especially true when you look at the speed deficit. A Greenland shark maxes out at a top speed of about 1.6 miles per hour. Let's put that in perspective. That is slower than a casual human walk. Meanwhile, a harbor seal, which scientists frequently find entirely whole inside the stomachs of these sharks, can easily swim over 22 miles per hour. So, how does a 1.6 mile per hour blind animal catch a 22 mile per hour seal? The answer is infinite patience. Operating in total darkness, the shark doesn't chase, it ambushes. It relies on a highly attuned sense of smell and electroreception to quietly, almost invisibly, drift up to seals that are sleeping in the freezing water. It doesn't need to be fast, it just needs the seal to be asleep.
Section 3. The Radioactive Eye Lens. Unlocking the Cellular Scale.
Now, what's really interesting about this slide is how researchers actually figured this out. to uncover the secrets of an animal that leaves no traditional biological trace because they don't have the calcified bone growth rings we normally use to date other sharks. Scientists had to rely on a brilliant breakthrough in 2016. They had to look past the macroscopic animal and dive right into the cellular scale of those corrupted eyes. Since they couldn't count bone rings, researchers extracted crystalline proteins from the very center of the shark's eye lenses. These specific proteins actually form before the shark is even born, and they never regenerate. They act as a perfect biological timestamp. To read that timestamp, scientists looked for the carbon-14 radiation pulse left in the global ocean by the atomic bomb tests of the 1950s and 60s. And what they found was wild. Only the absolute smallest, youngest sharks had this radiation. The massive adults, their core eye tissues had absolutely zero trace of nuclear fallout.
The sheer scale of this is captured perfectly in this sentiment. Its body chemistry belongs to a different era of the planet. I mean, it is simultaneously terrifying and awe-inspiring. Think about it. The tissues of the oldest Greenland sharks predate the atomic age entirely. Their cells were physically constructed from a version of Earth's oceans that quite literally no longer exists. They are sealed time capsules swimming through a modern world they biologically predate.
Section 4. The genetic glitch and the 2026 discovery.
But of course, science rarely stops at one impossible discovery. In January 2026, researchers published a groundbreaking study in Nature Communications that completely shattered our previous understanding of the shark's biology, and specifically that assumed blindness we talked about earlier. When researchers looked at the preserved retinas of sharks that were well over a century old, they were expecting to see severe decay. Instead, they found a genetic glitch. They discovered zero retinal degeneration, absolutely none. While a normal animal's eyes break down over time, the Greenland shark's genome possesses these unusually massive, highly active DNA repair mechanisms. Its cells are constantly fixing damage before it can even accumulate. It also has rhodopsin proteins that are perfectly tuned to capture the absolute faintest blue light of the deep ocean. So, the massive revelation? The shark isn't blind at all. Its DNA suppresses aging so incredibly well that it maintains perfect deep-water vision, and its eyes have simply evolved to see right through the parasitic scarring. It is actively fighting off biological decay at the molecular level for centuries.
But nature always demands a brutal trade-off for this kind of immortality. And for the Greenland shark, that trade-off is the number 150. A Greenland shark does not reach sexual maturity until it is a staggering 150 years old. Just think about the math on that. That means a female shark born right at the start of the American Civil War is only just now, today, becoming capable of having her very first pups. This intensely slow life history represents the absolute extreme of the evolutionary long game.
Section 5. The existential scale, a warning from the deep.
Zooming out to the existential scale, this slow-motion life brings massive philosophical and conservation implications. Because while the Greenland shark is practically immune to natural aging and cancer, it is incredibly fragile when it comes to the rapid, reckless pace of the modern world. It's a creature existing entirely outside our timeline, yet forced to survive our consequences. And it's a brutal warning from the deep. Because of that 150-year wait for reproduction, if humanity accidentally kills one adult female in a fishing net today, we wipe out generations of offspring that wouldn't have even been born until the year 2175. Tragically, humans have historically overfished these ancient giants, and not even for food. Their flesh contains trimethylamine and oxide, making it highly toxic unless it's intensely fermented into the traditional Icelandic dish, hakarl. No, we hunted them simply to render their massive livers into lamp oil. We literally spent centuries burning 400-year-old biological marvels just to light our lamps.
Yet despite absolutely everything we've thrown at it, the Greenland shark remains. It is nature's quiet, imposing rebuke to our modern obsession with speed and instant gratification. It doesn't need to be fast. It doesn't need perfect, unblemished eyes. It simply persists. Endurance, not explosive power, is the ultimate evolutionary triumph on Earth. By moving slowly, lowering its metabolism, and continuously repairing its own DNA, it has conquered the one thing human beings cannot: time itself. Which leaves us with this final, profound question to consider today. If an animal the size of a great white shark managed to hide its 4-century lifespan and mind-blowing genetic secrets from us until right now, swimming in the freezing dark of the Arctic, what else is down there? What else is older than our countries that we just haven't learned to see yet? Keep that deep-time dread and boundless curiosity with you. It absolutely changes the way you look at the world.